A matrix is just a rectangular array of numbers. You can think like a Excel spreadsheet. You can tell, we label these by how big they are. We count how many rows there are, and that's our M number, and how many columns there are will be our N number. So this will be an M by N matrix. So some examples, we're going to write this as an augmented matrix of the system of linear equations. We have a matrix, we have our X column, our Y column, our Z column, and then at the very end we have our numbers column that would give us our answers. And a lot of times, this is an optional line, but a lot of times we'll put that line there, and that's just kind of to indicate, to separate the variables from the number at the end. So we have on our first equation, this would be 5x minus y is like a minus 1y, and then a minus z is a minus 1z, and that's all going to equal 0. We have our x plus y equals 5. We have 1x, which is just a 1 here, a 1y. Now notice there are no z's, so I have to put a placeholder in for the z position, and that's going to equal 0, and then have 0 z's, and then that all equals 5. Now this third equation, we have 2 x's. Notice there are no y's, so I'm going to put a 0 in the y position, and then I have a negative 3z, and that's going to equal 2. Now, if I was going to label how big this was, I would count how many rows. There would be 3 by 4. This would be a 3 by 4 matrix. Okay, now we're going to write a system of equations that correspond to this matrix. Notice right here, I have 1x, and that's going to equal 1. So in this matrix, x equals 1. On the second equation, I have 1y equals 2, so y equals 2. And then for the third equation, I have no x's, no y's, no z's, and that's going to equal 3. So 0, x, y's, and z's equals 3. This is inconsistent. That doesn't work. So this would be a no solution. Okay. On number 3, we have 1x and 2 z's, and that's going to equal negative 1. X plus 2z equals negative 1. We have our second equation right here. This is 1y minus 4z equals negative 2. Now this third equation is 0 equals 0. That is always true. So this would be an infinite solution problem. Now, when we have infinite solutions, what we want to do is we want to write them so we have our x, our y, and our z all in terms of z. So if I look at this equation right here, y minus 4z equals negative 2, I'm going to add 4z to both sides. And so in my y position, I'm going to put 4z minus 2. Now for my x, I have x plus 2z equals negative 1. What I want to do for x is I also want to get it in terms of z. So I'm going to minus 2z from both sides. And I'll have negative 2z minus 1 for my x. So this would be a solution of the system all in terms of z's. And that's what you want to do if you get infinite solutions, because not everything is a solution. But it will be a solution as long as it's in this form. So there are infinite number, but not everything is a solution. Now, on this next number 4, we have an extra row. So what happens when we have 4? It adds a variable. We start with x, and then y, and then z, And then we're out of letters, and so what they end up doing is putting W next. So X, Y, Z, W, which is a little out of order, but that's the way that it works. So this is X is going to equal a 1 for that first equation. The second equation is Y equals 2. The third equation is Z equals 3. And the fourth equation is W equals 0. Okay, now a matrix is in row echelon form when the first entry is a 1, just like this, and there's zeros below that 1. The first non-zero entry in each row is a 1, and zeros appear below it, and any rows that contain all zeros are at the bottom. Okay, so we're trying to figure out, are these in row echelon form or not? We have a 1 here with zeros below it. The first non-zero entry in each row is a 1, and any ones have zeros below it. And there's no row that has all zeros to the left of the vertical bar. So this one, yes, this is in row echelon form. Okay, the second one, it has a 1 with all zeros below it, but in the second row, the first non-zero entry is a 2. So this is not in row echelon form. The third one, we have a 1 in the first spot with zeros below it. The first non-zero entry is a 1. And then if you have a row with all zeros, then this would be at the bottom, which is true. So this, yes, this is in row echelon form. This next one, we have a 1 with zeros below it. The first non-zero entry in each row is a 1, but if there's a row with all zeros, it should be in the denominator there. And so this would be not in row echelon form. Next one, we have a 1 with zeros below it. The first non-zero entry in each row is a 1, and there's zeros below that. And if I have a row with all zeros to the left of the bar, they are at the bottom. So this one, yes, it is. And this last one, we have a 1 with zeros below it. The first non-zero entry in each row is a 1, and there are zeros below that. There's no row without any with zeros in the whole row to the left of the bar. So yes, this is in row echelon form. Okay, now these are systems of equations. So for example, if I had 2x minus y equals 7 and x plus 2y equals 3, I could take those equations and put them in either order. I can switch them around and they still will work. And so that's why I can interchange any two rows. I can multiply any row by any non-zero number. So for example, if you have an equation that is true, 2 equals 2, you can multiply both sides by any number, and that will still give you something that is true. You can also take and add two rows together. So for example, if I had two equations, 2 equals 2 and negative 6 equals negative 6, I can add those together to get something, negative 4 equals negative 4, that is also true. So anytime you add equations, two things that are equal, you're going to get something else that is equal. So I can also do any combination in together. So I could multiply and add at the same time. And so we're going to do some examples of this, where first we're going to give you where the equation is, so they tell you what to do, and then we're going to kind of come up with what to do on the next one to get it in row echelon form. Okay, so here we're going to get our new row 2 by taking negative 2 times row 1 and adding row 2. So I'm going to take row 1 and I'm going to times that by a negative 2. and I'm going to add that to row 2. So I'm going to multiply this by -2, add it to second row, and then that's going to give me my new second row. So I have -2, 6, -6, and 10. And I'm going to add that to the second row. And then I'm going to put a new matrix over here, and I'm going to replace row 2 with that number. So I have -2 plus 2 gives me 0, and I'm putting that in the second row. 6 minus 5 is a 1. -6 minus 3 is a -9. And -10 minus 5 is a 5. Okay, now this next thing I'm going to do is I'm going to take 3 times row 1 and add it to row 3. So if I times 3 times row 1, that's going to give me 3, -9, 9, and -15. And then I'm adding that to row 3. And if I add these, I get a 0. -9 minus 2 is -11. 4 plus 9 is 13. And -15 plus 6 is 9, -9. And then I'm just going to rewrite that first row again. And that's the first part to get it in row echelon form. You want a 1 with zeros below it. We also, by doing that, our first non-zero entry in this row is a 1. Now, if we were going to continue, what we would want to do is we would want to use this one to get a 0 below it. So I would times the second row by an 11. And we usually want to write what we're doing. So I would say something like, I would want to times 11 times row 2 plus row 3. And that's going to give me my new row 3. And so you could write it in this form here, or you could say, like what we did here, you could say row 3 equals 11 times row 1, or row 2 plus row 3. So you can write it either way there. Okay, now we're going to take this system and we're going to solve it using row echelon form. And Gaussian elimination is what this is called, because it's from Carl Friedrich Gauss, and he came up with this method. And so we have our 1, -1, 1, 8, 2, 3, -1, -2, and 3, -2, -9, and 9. And that comes from the system where this is our x, this is our y, this is our z, and this is the number at the end. Okay, so now what we want to do is we want to have a 1 in this position, which we do. And so then we're going to take that one and we're going to use it to get zeros below the 1. So what I'm going to do is I'm going to take a -2 and times it by row 1 and add it to this row 2, and that will eliminate this variable here, and I'll be able to have a 0 there. So I'm going to have -2 times row 1 plus row 2, and that's going to give me my new row 2. I'll put that over here. So if I times that by -2, I get -2, 2, -2, -16, and then I'm going to add it to row 2. So -2 plus 2 is a 0. 2 plus 3 is 5. -2 minus 1 is -3. -16 minus 2 is -18. We want to get a 0 in this bottom position here. So since this is a 3, we're going to take that first equation and we're going to times it by a -3, so it eliminates when we add it to row 3. So we're going to take negative 3 row 1 plus row 3, and that's going to give me my new row 3. And so if I times that out, I get negative 3 here. I'm just going to take that negative 3 and times it through and put those numbers here. So I'm going to have a negative 3, a positive 3, a negative 3. 8 times 3 is 24, so I have a negative 24 here. And then we add those together. We have negative 3 plus 3 is 0. 3 minus 2 is a 1. 9 times negative 12. And negative 24 plus 9. Negative 15. And I don't have any reason to change my first equation, so I'm just going to write it all again. Okay, now so we want a 1 in the first position, and then we want zeros below. Now my first non-negative entry of each row needs to be a 1. However, I have a 5 here. I do have a 1 here, which I like, and so what I'm going to do is I can switch any two rows. So what I'm going to take row 2 and switch it with row 3. And then I'm going to write that in this next matrix here. So I have 1, negative 1, 1, 8, 0, 1, negative 12, negative 15, and 0, 5, negative 3, negative 18. So I have a 1 as the first non-zero entry here, but now I need to get zeros below it. So I'm going to use this 1 to get this 5 to be a 0. So I'm going to take negative 5 times row 2 plus row 3, and that will substitute for the new row 3. So we go ahead and times it by negative 5. That gives us 0, negative 5. 12 times 5 is 60. And 15, 30, 45, 60, 75. So 75. And then we add those together. So we're going to have 0 plus 0 is 0. We get another 0. 16 minus 3 is 57. And conveniently, 57 minus 18 is also 57. Now, we have a 1 with zeros below it, a 1 with 0 below it. Now I need to get this to be a 1. This equation right here is of the form 57z equals 57. So I need to get z alone. So normally I would divide by 57. However, division is not one of our properties, but I can multiply any row by a non-zero number. So instead of dividing both sides by 57, what I'm going to do is I'm going to times both sides by 1 over 57, which produces the same result as division. So what we're going to do is we're going to take 1/57 times row 3 is going to be my new row 3. And this gives us 1, negative 1, 1, 8, 0, 1, negative 12, negative 15, and 0, 0, 1, 1. Okay, now that we have it in row echelon form, we are going to use back substitution. We have x minus y plus z equals 8. Y minus 12z equals negative 15, and then we know that z equals 1. So I know that z equals 1, so what I'm going to do is I'm going to take that 1 and substitute it in for the z in the second equation. So I have y minus 12 equals, so negative 12 times 1 is negative 12, equals negative 15, and then I add 12 to both sides. So y is going to equal 3, negative 3. So now that I know that y is negative 3 and z is 1, I'm going to take those two numbers and substitute it in for the x of the first equation. So we're going to take x minus y minus a negative 3 plus z is a 1 equals 8. So this is x plus 3 plus 1 equals 8. And so if I, x plus 4 equals 8. So if I minus 4 from both sides, x has to equal 4. Now we want to write our system as an ordered triple. And so this would give me, you will always want to put your x first, then your y, then your z. And so that would be my answer there. Okay, now number 7, we're going to do the same thing. We're going to write it as a matrix. We have our x column, our y column, our z column, and then our number column. We have 2 x's, 1 y, no z's, and that's going to equal -4. Now this one, the second equation doesn't have any x's, but it has -2 y's, 4 z's, and that equals 0. And the last equation is 3x, 0 y's, and a -2 for my z. Now, very first thing I want to do is I want to get a 1 in this position. So I have a couple choices. I could divide this whole row by 2, or times it by 1/2, and that would give me a 1 here. However, when you do that, I would get a 1/2 here, and it's not very fun to have fractions, so we want to avoid them at all costs. And sometimes you can't. Sometimes you have to have fractions to be able to solve them. But I do notice that 3 is one number higher than 2. So if I take -1 and times it by row 1 and add it to row 3, that could give me my new row 1. So I'm going to take a negative for all of these numbers here. A negative is going to negative is going to be a positive, and then I'm going to add those two rows together. 3 minus 2 is a 1, and then I have my negative here. 0 minus 1 is a -1. -2 plus minus 0 is -2. And -11 plus 4 is -7. And then for my second row, very conveniently, these are all even. And so I'm going to take a -1/2 and times it by row 2, and that's going to give me my new row 2. So it's kind of like dividing by -2, but it's like multiplying. Multiplying by -1/2 is the same as dividing by -2. So if I divide this by -2, I get a 1, so a 0 and then a 1. Divide this by -2, I get -2. And 0 divided by -2 is a 0. Okay, now what I want, let's rewrite 3, 0, -2, -11. Now what I'm going to do, I have this a 1 right here, and what I want to do is I want to get zeros below it. So I'm going to take and times row 1 by a -3 and use that with row 3 to get a 0 in this position. And we're just going to add those together. So I'm going to take -3 times row 1 plus row 3 is going to give me my new row 3. So I'm going to have a -3 here, which is -3, 3, 6, and 21. And then we're going to add row 1 and 3 together. -3 plus 3 gives me 0. 3 plus 0 is 3. 6 minus 2 is a 4. And 21 minus 11 gives me a 10. And I'm going to rewrite 1, -1, -2, -7, 0, 1, -2, 0. Now I'm going to use this 1 here to make a 0 below it. So I'm going to times -3 times row 2 plus row 3 is going to give me my new row 3. Okay, we're going to take this -3 and times it through. We get 0, -3, 6, and negative 3 times 0 is 0. Add those together, and we're going to put it in the row 3 spot. We get 0, 0, 10, 10. And we have 0, 1, negative 2, 0, and 1, negative 1, negative 2, negative 7. Now our last step is to get a 1 in this spot here. And right now we have something like 10z equals 10. So if we divide both sides by 10, we'll know z equals 1. But we need to multiply when we're doing matrices. So we're going to take 1/10 times row 3 is going to be our new row 3. And that will give me we'll just rewrite the first row. And in the last position, we'll have 0, 0, 1, 1. So now we're going to write our matrix. We're going to take our matrix, write our equations, and use back substitution. So x minus y minus 2z equals negative 7. Y minus 2z equals 0. And z equals 1. So let's take that 1 and substitute it in for z in the equation above it. Y minus 2 times 1 equals 0. This is y minus 2 equals 0. So y has to equal 2. Now we're going to take our z and our y and substitute it into the first equation. So we have x minus y is minus 2 times 1 equals negative 7. I have x. This is minus 2 and minus 2 is minus 4 equals minus 7. Add 4 to both sides, and x equals negative 3. And we want to write our answer as an ordered triple where we have our x first, our y second, and our z last. Negative 3, 2, 1. Okay, now this last one, we're going to use a reduced row echelon form. And reduced row echelon form, it looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1 with numbers in the last position. So we're going to go through our first system getting a 1 here and then zeros below it, a 1 here with 0 below it, and a 1 here. And then we're going to kind of continue on by taking this one and going up, this one and going up. We're kind of doing it backwards. So let's first start by writing it as a matrix. We have our x, our y, our z, and our number at the end. 1, negative 2, 3, negative 3. 2, 1, 1, 4, negative 3, 2, negative 2, negative 2. Now, very first thing is you want a 1 here, which we have, and then we're going to use that 1 to make zeros below it. So I'm going to take row 1 and times it by a negative 2 and add it to row 2 to get us our new row 2. We will keep that first row the same. So I'm going to times this by a negative 2, and that's going to give me a negative 2, a positive 4, a negative 6, and a positive 6. And then we're going to add these two rows together here. And that's going to give me my new row 2. So I have negative 2 plus 2 gives me 0, 4 plus 1 gives me 5, negative 6 plus 1 is negative 5, and 6 plus 4 is 10. Then our third row, we're getting a 0 in this position here. We're going to take, I'm just going to erase some of this here. And this time we're going to take we're trying to get rid of this negative 3. So I'm going to take that first row and times it by a negative 3 times row 1 plus row 3 will give me my new row 3. So if I times this by 3, 3 times 1, oh, I lost a number. Let me add that back in. It was a 3 here. And I'm going to take my 3 and times it through. So we have 3, negative 6, 9, negative 9. We add those two up together, and that's going to be my new row 3 right here. So we have a 0, negative 4, 9 minus 2 is a 7, and negative 9 minus 2 is a negative 11. Okay, now we have a couple of options. So we took the 1, got zeros below it. Now I need a 1 in this position. A few different ways we could do it. We could take 5 minus 4 will give us a 1. So we could do row 2 plus row 3 to give us our new row 2. Or I'm noticing these are all divisible by 5. So what I'm going to do is I'm going to just take 1/5 times row 2 will give me my new row 2. Okay, so you could have done it either way. So here I have 1, negative 2, 3, negative 3, 0, 1, negative 1, 2. And that was 1/5. Row 2 became my new row 2. And 0, negative 4, 7, 11. Okay, now for my next step, I'm going to use this 1 to get a 0 below it. Okay, so I'm going to times 4 times row 2 plus row 3, 4 times row 2 plus row 3, and that's going to be my new row 3. This 11 had a negative with it, and so negative so negative 11 plus 8 is a negative 3. Okay, so let's rewrite 1, negative 2, 3, negative 3, 0, 1, negative 1, 2. Now I have I want to get the last step to get it in row echelon form is to get a 1 in this position. This is a 3, this is a negative 3, so this would be like 3z equals negative 3, so I'm dividing by 3. But when we're doing matrices, we're multiplying by a number. So I'm going to multiply 1/3 times row 3. It's going to give me my new row 3. So I have a 0, 3 divided by 3 is 1, and negative 3 divided by 3 is a negative 1. Okay, now we're going to take our line right here, and we are going to use this one here to get zeros above it. So if I add row 2 and let's write the rest of this right here. 1, negative 1, 2, and 1, negative 2, 3, negative 3. We're gonna use, we're gonna add row 2 plus row 3 will give us our new row 2. So if by doing that, I'm going to add 1 and negative 1, and that will give me a 0 here, but it's going to keep the integrity of this 1 here. So we're going to have 0, 1, 0, and then 2 minus 1 is just a 1 here. So now we know what y and z are. We're going to use this 1 now to get a 0 in this position. So since this is a positive 3, we're going to times this bottom one by a negative 3. Negative 3, row 3 plus row 1 will give us our new row 1. So I'm going to have a negative 3 here, and then I will get 0, 0, negative 3, and 3. Which gives me 1, negative 2, 0, and 0. Okay, now for the last step, I'm going to use this one to make a 0 in this position. So I'm going to take the second row times 2 and add it to row 1. So 2 times row 2 plus row 1 will give me my new row 1. And that will get it in reduced row echelon form. So if I times row 2 by 2, I get 0, 2, 0, 2, and then I just add it to row 1. So 1 plus 0 is 1. Negative 2 plus 2 is 0. 0 plus 0 is 0, and 0 plus 2 is 2, which gives 0, 1, 0, 1, 0, 0, 1, negative 1. Okay. So x equals 2, y equals 1, and z equals a negative 1, which is 2, 1, negative 1.